Welcome to the properties of parallelograms part 2. This video we are going to focus on proving that a quadrilateral is a parallelogram, and it won't take very much time at all. So let's get started. So getting right into it, in method 1 we're going to prove that both pairs of opposite sides are congruent. So in that we need to show that AB is congruent to DC and that AD is congruent to BC. If that's the case, if both sides are congruent, then ABCD is a parallelogram. And so what are we going to use? We're going to use the distance formula. So let's jump right down into a problem here and see if we can use this. It says to determine whether the figure is a parallelogram using the distance formula. So first, let's draw our quadrilateral, and we're going to have AB, CD, and we just use the alphabetical order that they gave us to go around. Now, just so you know, we could have put the A anywhere, and we could go around in this order too. So this is okay, this is okay. What we can't do is call this A, B, C, D. That is a no-go. So start with A and go around one way, or start with A and and go around that way. Now the reason you want to draw the picture is you want to understand which side you're trying to prove congruent. So the first two I'm going to choose is AB and CD. So let's get into the setup for AB. So as you can see, I've written my points over here, copied it from what was given to me. -7, 4 is A, 1, 2 is B. I've labeled them x1, y1, x2, y2, and I've set up the AB distance formula program right here. So now all I need to do is just populate in my values. So x2 is going to be 1, and x1 is going to be -7. y2 is going to be 2, and y1 is going to be 4. Now I'm just going to start collapsing this down. 1 plus 7 is 8 squared, and 2 minus 4 is -2 squared. And that's going to be 64 plus 4, which is the square root of 68. So I'm just going to write up here that AB is equal to the square root of 68. And now I'm just going to repeat that for CD. So once again, just talking my way through it, x2 is going to be 1, x1 is going to be 9, y2 is going to be -6, and y1 is going to be -8. Now when I go to crunch this down, 1 minus 9 is -8 squared, plus -6 plus 8 is going to be 2 squared, and I see that 8 squared and 2 squared again, so that's going to be 64 plus 4, which is square root of 68. So CD is equal to the square root of 68. Now what we need are the lengths of BC, and we also need the lengths of AD. So why don't you go ahead, press pause, and work through those and see if you can get the same answers. Press pause now. Well, so far I end up with the square root of 164 for BC. Let's see how we make out with AD. Again, I urge you to press pause and work it through on your own first. Otherwise, you're copying, you're not learning. So again, I get square root of 164, so I got BC is equal to square root of 164, and AD is equal to the square root of 164. So since I have both sides congruent, right, we have both sides that are congruent, then yes, ABCD is a parallelogram. All right, we're in good shape. That's the first method, using the distance formula 4 times to show that both sides are congruent. Both pairs of opposite sides are congruent, that is. Okay, method number 2 is showing that both sides are parallel. So if I'm going to show that both sides are parallel, I have to understand that parallel lines have the same slope. So if I'm trying to show that AD and BC are parallel, and AB and DC are parallel, if I'm trying to show that, then I'm going to need the slope formula. Remember, slope is y2 minus y1 over x2 minus x1. Now, after having worked the distance formula over so many times, slope formula should feel like a break. Again, let's put this into action. Determine whether the figure is a parallelogram using the slope formula. So, first things first, let's draw it out and let's label it. We got w, x, y, z. And I want to show that these guys are parallel, and I also want to show that x, y, and wz are parallel. So, let's just get on with it. Slope of, say, x, y first is going to be, and I'm looking at my x and y coordinates, it's going to be negative 13 minus a negative 6 over 5 minus 1. Negative 13 plus 6 is going to be negative 7, and 5 minus 1 is 4. So we have negative 7/4. Okay, that's our first slope. Now, the slope of xy should be congruent to the slope of wz. So we go up here and we start working this through again. I got my wz coordinates over here, and we work it through. We say negative 12 minus negative 4 all over 1 minus a negative 7, and that's going to be 8 over 8, which is 1. I'm sorry, this is a negative 8, which makes this a negative 1. And all of a sudden, we got ourselves a problem. These slopes are not equal, so at this point, I think I could just stop and say, no. No. XY is not parallel to WZ, right? And this is going to be our answer. And where's our proof? Right here. Why didn't we do the slopes of the other two? Doesn't matter. I happen to get lucky and start with the two that weren't parallel. It asked me to determine if this was a parallelogram, and the fact of the matter is, it's not, because these would have been the same answer. So that's all we need. What if it was a parallelogram? These two would have been the same, and then I would have had two more slopes for xw and yz. And if these were the same and these were the same, then we would have said, yes, x or wxyz is a parallelogram. That's not the case, so we're all set. Move on. Our third method is to show that one pair, not both pairs, of opposite sides are congruent and parallel. So when we look at this, we're just saying, hey, AB and DC are congruent and they're parallel. In the other two methods, they were either both congruent or both parallel, opposite sides. This one, if you pay close attention here, uses the same opposite sides for both congruency and a parallel relationship. So this, we're going to use the distance and the slope formula. Let's put it into action. Okay, so first we're going to draw our potential parallelogram. J, K, L, and M. Again, I'm just starting at the letter they gave me and working my way around. So now let's just pick a set of sides. How about JK and LM? First, let's see if they are congruent. So we're going to look at JK over here, and then we're going to start with the distance formula. So JK is equal to, right, and we got our parentheses, so let's see, we're going to go with negative 5 minus a negative 9 all squared, and then we're going to go with 1 minus a negative 2 all squared, and so negative 5 plus 9 is going to be positive 4 squared, plus 1 plus 2 is going to be 3 all squared, and that's going to be 16 plus 9, which is the square root of 25. And that's JK. Now, let's move on to LM. LM, I'm going to start with negative 3 minus 1, all squared, plus negative 7 minus a negative 4, all squared. And that's going to give me negative 4 squared plus negative 7 plus 4 is going to be a negative 3 squared. Oops. And that gives us 16 plus 9, which is the square root of, I'm squeezing it in there, the square root of 25. So boom, boom, we have that, yes, indeed, they are congruent. So let's move on to the slope now. Now let's not forget that I'm still working with JK, so I have the slope of JK is going to be equal to the difference of the y's, so 1 minus a negative 2, and then the difference of the x's, negative 5 minus a negative 9, which is equal to 1 plus 2, which is 3, over 5 plus 9, which is 4. So 3/4 is the slope of JK. Now how about LM? LM is going to be the difference of the y's, negative 7 minus a negative 4, all over negative 3 minus 1. That's going to be negative 7 plus 4, which is negative 3, and negative 3 minus 1 is a negative 4, which reduces to a positive, right, because I got a negative over a negative, and so I have the same slope. So these are both congruent and parallel. So yes, JKLM is a parallelogram. All right. Press pause if you need to and tighten up any notes that you might be missing. So just to recap, we have 3 methods, 1, 2, 3, of proving parallelograms are in the coordinate plane, or proving that a quadrilateral, I should say, is a parallelogram. The first one is to show that both pairs of opposite sides are congruent, and we'll use the distance formula to do that. Or we could prove that both pairs of opposite sides are parallel, and we'll use the slope formula to do that. Or we could show that one pair is both congruent and parallel using the distance and the slope formula, but for only one pair of sides. And so it doesn't matter if you choose the top and the bottom or the left and the right. That's up to you. If it is, it works on both. If it isn't, then it will show that there is some sort of a discrepancy. All right, so that discrepancy in this last one might not show up for the distance formula, it might show up for the slope, or it might show up for the slope but not the distance formula. And when these things are not parallelograms, sometimes you have to do a lot of work before you find out, and sometimes you find out early on in the process. It's kind of, just sort of luck. What are you going to do now? So I did numbers 1, 3, and 5. You're going to go back and do 2, 4, and 6. Now, just a little caveat, only one of them is going to be a parallelogram, but you're going to do all 3 to show that only one works. When you're done, you're going to check in. After you check in, then you're going to go and complete 8 through 12, the back side of that homework section. You already did 1 through 7. Now you're going to do the back side. And just so you know, 2 of the 3 are parallelograms. Make sure you pay attention to which version. On 10, you use the distance formula, 11, you use the slope, and 12, you use method 3. So you're going to exercise the all 3 methods, okay? You're on your own. Oh, one last thing. I wanted to give you a little help on 8 and 9. Right here, BCD is 51, so this angle right here is 51 degrees. That makes this angle right here supplementary to 51, so 180 minus 51 will give me that big angle right there. Once I know the big angle, I can get the little angle right here because I know that this is 55. So 55 plus something equals whatever that big angle is. So first I figure out the big angle by subtracting 51 because they're supplementary. Then I can find this little angle right here by subtracting 55 from the big angle. And lo and behold, this little angle right here and this little angle right here, well, they're alternate interior, which makes them congruent. That part is 14x plus 4, so that must be equal to whatever that little angle is. Aha! If that was confusing, just rewind it, listen again. Now over here, we got angle VST is 5x plus 23. and the measure of VUT. Well, where's VUT? We'll go in blue for VUT. VUT is right here. That's 8x minus 49. Well, I think those are opposite angles. And opposite angles in the parallelogram are what? They are congruent. So I guess that's easy enough. Well, now what do? Once I solve for x, I can actually substitute x back in and get the measure of those angles. And then again, I know that this angle right here and this angle right here are consecutive interior, which means that the big angle here and the big angle here add up to be 180. Well, I know I can get this because that's VUT. That's this. Once I get the value of x, I can find that measure. And once I find that measure, I can find this measure. And if I take 20 degrees away from that, I will find the measure of this piece right here. The last thing they asked me for was the measure of SVT. SVT is that little angle that I'm trying to talk about. Hopefully that was helpful. Good luck. Don't forget, 2, 4, and 6 first. Check in. Then get going on the homework 8 through 12. Right? This is homework. This is classwork. Check that in first.